It began quietly, without fanfare, deep within the industrial heart of America, the kind of place where diesel fumes and steel grit once defined progress. Rows of massive freight trucks lined the horizon, their engines silent, not because they were broken, but because they had evolved. 100 of America's most powerful diesel trucks, machines that once consumed thousands of gallons of fuel every month, had been reborn. Their engines, transmissions, and systems had been re-engineered with a breakthrough technology that defied everything the transportation industry once believed possible: self-powered energy. No gasoline, no charging stations, no constant maintenance of batteries, just continuous motion driven by an onboard power source that seemingly generated its own electricity. The revolution had begun. This wasn't a story about electric trucks replacing diesel, or about some distant future still being tested in labs. This was happening now, across highways in Texas, Arizona, Nevada, and California. Trucks once powered by combustion, now running entirely on self-sustaining energy systems. The concept, inspired by early prototype research in Africa and refined by a coalition of American engineers and energy innovators, had matured into a working reality. Each truck carried within its chassis a next-generation conversion module, a compact, self-powering generator designed to harvest, convert, and recycle energy at near-zero loss. The technology wasn't magic, it was engineering brilliance born from necessity. With global fuel prices rising, emissions laws tightening, and logistics costs spiraling, America's trucking industry needed a breakthrough. What it got was a complete transformation. The project started as an experiment under a small R&D team in Nevada known for unconventional energy systems. Their idea was to retrofit existing diesel trucks rather than build new fleets from scratch. The goal was simple but revolutionary: make the old new again. They called it Project Titan. Using high-efficiency electromagnetic drive systems combined with solid-state energy modules, they managed to convert one of the oldest 18-wheelers in their fleet into a self-powered prototype. In early field tests, that single truck ran continuously for 700 miles, without fuel, without external charging, and without any measurable energy loss. Word spread fast, and within months, logistics companies, freight corporations, and even government observers began to take notice. By mid-2025, the pilot fleet expanded to 100 trucks. Each vehicle was equipped with custom self-powered modules, redesigned drivetrain components, and intelligent control systems that manage power output based on load weight, terrain, and real-time driving data. The result was astonishing. Trucks that once guzzled diesel at 6 miles per gallon were now achieving the equivalent of infinite range. Emissions dropped to zero. Maintenance costs fell by over 80%, and most remarkably, drivers reported a smoother, quieter, and more responsive performance than anything they'd ever experienced behind the wheel of a diesel rig. This wasn't more than innovation, it was disruption. The American trucking backbone, responsible for moving over 70% of all freight across the nation, was evolving faster than anyone predicted. Companies that once relied on traditional diesel fleets were now signing deals to convert their trucks to self-powered systems. Engineers described it as the beginning of an industrial metamorphosis, a once fossil-fueled economy learning to sustain itself on pure, self-generated energy. The modules inside each truck were sealed, maintenance-free, and designed to last decades. While the exact mechanism remained under proprietary secrecy, insiders hinted that it involved advanced electromagnetic resonance combined with kinetic energy recycling, an elegant balance of motion and magnetism. Across the country, reactions were mixed. Skeptics questioned the validity of a system that could seemingly create its own power, yet the results spoke for themselves. Freight companies participating in the trial reported real-world performance data that couldn't be ignored. Zero downtime, consistent power delivery, and operational costs nearly eliminated. Federal transportation agencies began investigating, not for fraud, but for potential regulatory frameworks. What happens when a truck no longer needs fuel or charging stations? How do you measure emissions for something that produces none? America was watching a new industrial era unfold, one truck at a time. On the open highway, these converted trucks looked no different from their diesel ancestors. The same rugged frames, the same heavy-duty wheels, the same thunderous presence, but their sound had changed. Gone was the deep growl of a combustion engine, replaced by a near-silent hum, smooth and unbroken. Drivers described it as surreal, like piloting a jet powered by silence. Fleet managers saw numbers they had never seen before. Shipping costs dropped dramatically, delivery time shortened, and environmental compliance became automatic. Some logistics companies began branding their fleets with green lightning insignias, a mark of the new power, a visual symbol of America's shift towards a post-fuel future. Every major industry has its turning point, that moment when tradition and innovation collide. For American trucking, that moment came when the 100th converted truck rolled out of a Nevada facility, its diesel engine replaced by a compact, humming self-powered system no bigger than a conventional battery pack. It was a statement to the world. The era of fossil-fueled freight was ending, and the era of self-sustaining transportation had begun. The conversion was cost-efficient, scalable, and remarkably compatible with existing diesel infrastructure. Truck stops, once filled with the smell of diesel exhaust, began installing diagnostic and calibration hubs instead, places where self-powered systems could be monitored digitally rather than physically refueled. What's most extraordinary is the collaboration behind it. Unlike the secretive tech projects of Silicon Valley, this revolution grew from open cooperation between small engineering firms, universities, and independent inventors, all united by one vision: freedom from fossil dependence. The system's core design principles trace back to energy pioneers who believed that motion itself could be harnessed perpetually. While the idea had existed for decades, it had never reached industrial application. Until now. America, a land once powered by oil and coal, was now leading a revolution based on clean, continuous motion. The ripple effects extended far beyond trucking. Energy analysts predicted massive shifts across logistics, manufacturing, and even military sectors. If heavy-duty trucks could operate indefinitely without refueling, the implications for cost reduction, sustainability, and infrastructure were unprecedented. Every converted truck wasn't just a vehicle, it was a proof of concept for a self-powered economy. And while the world debated, America's highways became living laboratories where the hum of innovation replaced the roar of diesel.